Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve a Leetcode question number 2859, sum of values at indices with k set bits. You are given a 0-indexed integer array nums and an integer k. Return an integer that denotes the sum of elements in nums where corresponding indices have exactly k set bits. The set bits in an integer are the ones present when it is written in binary. For example, the binary representation of 21 is 10101. Which has 3 set bits, right? So this is a question problem statement. They are asking us to sum the elements that have a indices in which the indices have the set bits equal to k, right? So just see this example. For 0th index, I have 0 set bit. For first index, I have 1 set bit, k also 1. So I can say the first index is part of my answer. So 10 is my part of my answer. 2 has only 1 set bit. So I can take this one also in part of my answer. So 10 plus 1 is equal to 11. Now 3 has 2 set bits. No. 4 has only 1 set bit. So it also my part of the answer. So what is the fourth index? 2. So 2 is added to my answer. So already 11. Now 11 plus 2, it's 13. Right? So this is the example. See here. This is the example they have given. Now how to approach this problem? How to approach this problem? It is so simple, right? First, just think. Just take the array. This array, for example, and what are the indices? Let us take indices are 0, 1, 2, 3, 4. Now I want to traverse in this array and make each indices to pass into a function. Say there is a function. Inside this function, I will pass one by one indices and check whether the indices have set bit, and return this function will return the number of set bit. Set bit, right? So this is the overall view. Now this part is clear. Now how to write this function? Okay, let us think about it. First of all, we shall take in this for 4, maybe 4, right? 1 0 0. Now as we know how we find a binary representation, by dividing each value by 10 in decimal number, right? In this, just listen carefully. First, I take this bit. I take this LSB. I already told you how to take the LSB bit, right? I take this LSB bit. Check whether this LSB bit is 1. No, it's not 1, right? So I don't update. Now move to right. Shift to right. Right shift the element. Now it will be like this. Now see whether this last bit, LSB bit, is 1. No. Again right shift. Whether this 1 is LSB is 1. Yes. Now increase my count to 1. Right? Now again right shift. It will be 0. So terminate because there is no value. All value are exhausted. Right? That's all. Now terminated. So this is the procedure. Now return this result. Right? If the result is equal to the k value, then I can return what? I can make that element as a part of my result, right? So this is the first approach. So telling about the time complexity and space complexity. What is the time complexity and space complexity? Time complexity is O of n, because we are traversing one by one, right? Into log n, because we want to find each and every binary representation. Each and every set bit in the indices for this index, right? And space complexity is O of 1, because we didn't use any auxiliary space. Fine. Now coming to the second approach. The second approach is very important approach, Brain's algorithm, right? So what is meant by Brain's algorithm? Let us take an example. Maybe 8. No. Maybe 7. It will be more clear when we are using this 7. The binary representation of 7 is 1 1 1, right? Brain's algorithm says that take the number and do AND operation with that number minus 1 and store in that number, so that by doing this each and every time when this process occurs one time, one set bit will gone to 0, and another time when we do this process, the second set bit will set to 0. So this states that at how many count the n becomes 0, I can say the number of set bits is that number, right? Let me explain this solution. Just see here, 6. 6 minus 1, sorry, 7. 7 minus 1, it is 6. Put 6. Put 6 here. 1, 1, 0, right? Now, do AND operation. While doing AND operation, I will get 0, 1, 1. Increase my result to 1. Fine. Now again, this is 6. Sorry, this is 6. 6 minus 1, it is 5. Put 5. Put 5. Now do AND operation. 0, 0, 1. Right? Now increase my result to 2. Now this is what? 4. Now 4 minus 1, 3. So put 3 and do again AND operation. It will be wholly completed to 0. Now stop here and increase it by 3. Now seeing this, we can clearly state that, see here, at this step number 1, my first set bit is set to 0, right? At step number 2, my second set bit is set to 0, right? At step number 3, my third set bit also made to 0, right? So I can say in each step, one set bit is set to 0, Fine. This is my observation. So this is the Brian's algorithm. Fine. Talking about time complexity and space complexity. What is the time complexity? O of same n log n. Because for this we use we go for each and every bits. For numbers like this, we go for only one time, because we just put like this and make everyone as 0 and count will be +1 only, right? For this, the time will be taken very less amount, but still for doing like all bits set to 1, in that case it runs up to each and every bits, right? So it is n log n. Space complexity is O of 1. Fine. So this is the time and space complexity. Can we still optimize this approach? Yes. How can we optimize this approach? Let us consider this is some array. Take 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe first of all, let us take what are the number of bits in 0. Take any other color. What is the number of bit of 0? Set bit in 0. What is the number of set bit in 1? Right? Now let us think in different way. Like for 2, what is the binary representation? It is 1 and 0, right? It is 1 and 0. How can I derive the number of set bits of this 2 from previous elements, How can I derive? Let us take if I can make 2 divided by 2, so it will be 1. 2 mod 2, which is equal to 0, right? I have derived this two elements, right? We already know what are the set bits in 0 and 1. I can derive like this. 2 divided by 2, it is 1. 2 mod 2, it is 0, right? So according to this, I can take what is set bit in 1? Set bit in 1 is, first of all, I write here. It is 1, it is 0. Set bit in 1 is 1. Set bit in 0 is 0. So add this 2. My answer is 1. I can update the answer as 1. Right? Understand this? Fine. No. Again. Take for 3. 3 divided by 3 is equal to, 3 divided by 2 is equal to 1. And 3 mod 2 is equal to 1. So what is the set bit of 1? It is 1. What is set bit of 1? Again 1. 1 plus 1 is equal to 2. Right? So I update 3 as 2. Fine. Understand? Now same procedure for 4. Now I am going to do for 4. 4 divided by 2 and 4 mod 2. 4 divided by 2 is equal to 2. 4 mod 2 is equal to what? 0. So here the set bit is 1. Here the set bit is 0. Right? So 1 plus 0 is equal to 1. Fine. So it is 1. Now same thing for 5. 5 divided by 2 is equal to 2. 5 mod 2 is equal to 1, right? So 1, so the set bit in 2 is 1, the set bit in 1 is 1, so plus is equal to 2. So update, fine. Now same procedure for up to this 9. For this 6 I will take what are the elements, 3 and this 0, right? So 3 and plus 0, so 2 plus 0, which is equal to 2, right? For 7, 3 plus 1, 3 plus 1, so 2 plus 1, which is equal to 3, right? For this 8 I will take 4 plus 0, 4 is 1, 0 is 0, so 1. For 9 I will take 4 plus 1, so 1 plus 1, which is equal to 2. I can take like this. So this approach is called dynamic programming approach. Because we are just storing each and every result. We are storing each and every result in an array like it is a memory, and whenever we want we can access it and use it, right? So it is called as a dynamic programming approach. So talking about a time and space complexity. So what is the time complexity? O of n, because we haven't computing any set bit. We have only initialized this 2, and by using this 2 we have derived all this, right? What is the space complexity? It is O of n, because we are using this auxiliary space, right? So this approach is very important, very important approach. Okay, this dynamic programming approach. Just once more see this, you can arrive how come a dynamic programming approach came into the role in this program, right? Let us see the code. See here, this is the first approach. This here for num in range of len of nums, val is equal to nums of num, count is equal to 0. I am just going to count. Now I have already told you how to count. First we want to check whether the LSB is a set bit. If LSB is set bit, I want to count 1, and then I want to reduce the number by 2. That is, I want to right shift that number, right? If the count is equal to k, after doing all the process, if the set bit is k, I will add to the result, right? So this is my first approach. Let us run it. Fine, it is run successfully. Now second approach is Brain's algorithm approach. See here, same thing, but here alone it differs in code. See here, instead of using this line, I will use num is equal to num and num minus 1, so that one set bit will be cancelled. In each iteration, and when the number becomes 0, the iteration will stops, right? So this is the Brain's approach. Fine, it is running successfully. Now coming to the last approach is a dynamic programming approach. Just see here, I am declaring a bits array. In that 0, and I am declaring for length of nums. Now if len of nums is greater than 1, bits of 1 is equal to 1. Most of the programmers will forget this. Okay, you should use this line to avoid some edge cases, right? Because sometimes the elements may be only one element. In those conditions, it will be failed, right? So you have to use this. Then for I in range of len of nums, set bit is equal to bits of I mod 2 plus bits of I divided by 2. I have already told you that if I want to have the set bit of 7, I will divide 7 and take the set bit, and I will mod 7 and I will take set bit. Why? Because just listen here, only one minute. See here, 7, it is 111. When I am right shifting it, it becomes 11. This one will be gone, right? This one is gone, right? Here there are 2 set bits. If we see for this 1 we have 2 set bits, but still we have to add this 1, so that only we will put plus 1, so it will be 3. Fine. So this is the approach. That's why I'm using this condition. Now bits of I is equal to set bit. If set bit is equal to k, I will add the current element, right? That's all. So this is the dynamic programming approach. Let us run it. Let's check for this approach. Yes, it is submitted successfully. So these are the 3 types of approach. You have to be conscious while using these approaches, right? If they don't ask for any time complexity or time limit exceeded, you can use the above two approaches. But still, when they want to reduce the time and you can use space, you can use this dynamic programming approach. Thank you.